Hello and welcome to Computer Tech and More. Today we're going to be testing out the ROG XF120 Whisper Quiet Power Management Fan, and this is the first video in my sequence of testing fans, and I'm going to have data for my NF-F12 power management and my Cougar CP-12Hp as comparison data points. So in my previous video I talked about my testing methodology and why I'm testing the way I am. In this video, I'm going to just be focusing on, well, how they did in the tests with graphs and other data, and I'll have timestamps down below so you can jump to whatever sections you find most applicable. Alright, first let's do our open box of the ROG Strix XF120 Whisper Quiet Power Management Fan. I don't have the boxes for the other fans, so we're going to be taking a look at them on the webpage screen, and I'll talk about the characteristics of those fans, while this one I can basically use the box, and we'll also be taking a look at the advertising on the screen. So it's got a maglev bearing, says it's got a 22.5 decibel, 62.5 CFM, and it can do 3.07 millimeters of H2O, so that it's static pressure capabilities. On the other side, let's see if I can get that in nice focus. There's its maglev bearing. Levitation technology, it's not really anything new. They're just going to call it whatever they want. But magnetic levitation bearings are basically ultra smooth as opposed to like a ball bearing type one. And then grooved fan blades. So a feature on the fan blades we'll take a closer look at. That's supposed to help redirect airflow. Precise engineering grooves on the fan blades direct and focus air to flow smoothly along the blades for reduction in airflow separation. This increases the fan performance. So you would need CFM analysis in order to do that, and that CFM stands for computational fluid dynamics. And direct flow frame, so there's some features on the frame to help it direct airflow. 1 watt of power, fan standing voltage, some amperage, its weight, RPM 1800. So the static pressure and max airflow obviously are at the maximum fan speed, and you're going to notice different speed or different values at different speeds. Alright, let's take a look at the fan. So this isn't RGB, and I specifically did not choose the RGB version because I just really wanted to just test out the fan. And since I'm going to be testing it in a case where I won't, or in a situation where I won't have access to RGB, it didn't really matter as long as the performance is similar. And the specs of RGB versions and non-RGB versions were basically similar, so I felt that that was fine. Okay, let's see what's in here. Cable feels pretty standard, silicone, like rubberized silicone covering, so it's black like the rest of the fan. Got your grommets, screws, fan splitter. Alright, let's take a look at that fan. Well, has a little groove on the top. That must be that groove that I talked about on the packaging to help prevent flow separation, which is a real thing, believe it or not. You got model number on there. I like how it's just black. It means it won't, with the lettering it's not too shiny, so it'll blend into your case pretty well if you like that front. Looks pretty good while spinning. The holographic looks pretty sweet. The fan blades are kind of halfway between a static pressure style blade and they're leaning more towards static pressure, but like compared to the Noctua, what was it again? NF-F12X25, you can see that they're a lot thicker, which is better for higher pressure applications. But we're going to have data for all the different types of fans as I start filling it out. Let's go to the product page and see what everything looks like on there. Before we get into the graphs, I just want to show my data points. You can record it, take it down, and use these measurements for your own purposes if you want. So, all right, let's go to the next fan in this group. This one is for the Noctua NF-F12. The next fan in this group of testing was the Cougar CF-V12Hp. Unfortunately, it's no longer being sold. I'm not sure if I stated earlier that I think it was still being sold, but I've verified that it's out of stock wherever I could look for it, basically. And the last fan in this group is the Asus ROG XF120, and here is its data. I'll leave it up for a couple seconds. You can pause the video to take down the data points if you wish. For the sake of demonstration, this is the data charts that I've used to generate my graphs for the airflow across distance at different noise level or noise normalized 100% through the cooler CFM data as well as the noise data. So now that we have all that out of the way, let's take a look at some graphs. Next up, we have individual graphs. As we look at these graphs, let's talk about what we're looking at. In RPM versus speed, which is right here, at a distance from the fan. As RPM increases, so does the airspeed, and it should also be almost linear. Each color represents a distance from the fan and looking purely at RPM versus speed. So right here, we can see that this is 14 inches, this is 11 inches, 9 inches, 6 inches. So as you get closer to the fan, your airspeed goes up, and as your RPM drops, everything gets closer together, so your airspeed drops. And many of them are almost linear. Let's look more closely at how airspeed drops over distance from the fan as on this graph. Here, each line represents a fan RPM. The very best fan ever would have a flat line, meaning that there would be no drop in airspeed over the distance. But in the real world, we want to see a linear drop and as slow a drop as possible. That indicates that the fan is optimized to push air through a case rather than spreading it out. If it's spreading it out, the air will slow down more quickly as you get further away from the fan. So you really want to see it be as slow a drop and as fast as possible as you get towards the back of the case. This next graph is RPM versus airspeed through a cooler. And here it's not quite linear, it's a little bit of a polynomial. It's got a little bit of a curve to it, but it overall is that sort of shape. And the last graph is a flow rate, CFM, so cubic feet per minute versus RPM. RPM is vertical and horizontal is the CFM. And on this graph, you'll see a average fan. That is a composite fan from the fans that I've tested currently, and it will change over time as I do more fan testing. But for the purposes of my next few videos, it'll remain the same from the 9 or so fans I've already tested. All right, let's take a look at the other fans real quick, and then we'll go to the groups as to how they all look together. All right, here's the Cougar CF-V12Hp. It's airspeed over distance at specific RPMs that you can see on there. It's airspeed through the cooler. It's very linear. And last but not least is the CFM versus RPM. So realistically, you actually want the fan to perform better than that curve. That would indicate a much better fan. My camera seems to be really freaking out with its focus. All right, let's move on to the last fan in this group. And this is the graphs for the ROG XF120. So again, the different distances and colors versus the airspeed. And vertical is RPM, horizontal is airspeed. All right, the next graph is specific RPMs again. Airspeed versus distance at the RPMs listed in different colors. And you can see here that at the highest RPM, it has the steepest drop off, which leads me to believe that its airflow coming out the back is not particularly concentrated. But we'll see how it compares to the other fans in the next set of graphs coming up. And this one is the RPM versus airspeed through the cooler. It's very linear, which makes a lot of sense. The fan blade design looks very pressure optimized, and the thicker cooler of my Noctua leads it to be a little bit better for a pressure optimized fan versus an airflow optimized fan because of the thickness of the heatsink. It's not a radiator. So this leads me to believe that the fan would perform pretty well on a radiator. And last but certainly not least for these individual ones is CFM versus RPM. Again, CFM is horizontal, RPM is vertical, and it's a little bit below the line. It's very linear in shape. The composite calculated one is mostly linear in this section, as it at the bottom it's got a little bit of a odd point off to the side there. All right, so next we have the comparison graphs where I have all the fans that were in this group of testing. So first up is noise normalized testing. I chose a reading of 42 decibels for my noise normalized floor. Again, my noise floor in my office is not particularly low, so I had to choose a number that was kind of reasonable for what I could do, and I had the microphone placed really close to the fan. But the 42 decibel mark was chosen because it was the RPM level of the Noctua A12X25 that I found relatively silent in my old case when I still had an AIO. So that's why the noise normalized value was chosen at 42 decibels. Also note that that is not a true 42 decibels, so this isn't like true noise level, it's like a comparative noise level. So in noise normalized testing through a cooler, which is this first graph, the Asus ROG XF120 ran at 875 RPM. The Noctua NF-F12 ran at 640 RPM. And the Cougar CF-V12HP ran at 1,110 RPM. And again, your values may be up to, I believe, 10% different, leading the Cougar to be the best performer, making me really wish that it was still for sale. And the ROG had a airspeed of 0.55. The Noctua NF-F12 had an airspeed of 0.35. And the Cougar had an airspeed of 0.9, with an average fan being at 0.7222. This next graph chart is still noise normalized, and it's air through a case/distance from the fan, and the Cougar right here in this blue line is again the top performer, with this brownish line being an average fan and the ROG and the Noctua being relatively unimpressive here. When the fans could stretch their wings at 100% RPM, the ROG XF120 is the top performer at 1800 RPM and an airspeed of 1.6 meters per second. The Cougar CF-V120HP ran at 1,570 and an airspeed of 1.45, with an average fan having an airspeed of 1.6 meters per second. So the ROG performed about what the average fan, my average fan is expected to perform with my current number of fans tested. At 100% fan speed, in case airflow testing, the CF-V120HP, the Cougar, is the best at 1,590. So again, it's a little bit different than the other test, and that's within norms for fans, and had a decibel reading of 49 decibels. But the ROG XF120 is right behind it, but is significantly louder at 55 decibels, with its RPM being at 1,860. A note on this graph, the average fan actually outperforms all three of these fans. Next up are the CFM graphs. First is the noise normalized. As I have noted, a composite average of fans at the performance is at the bottommost line in that brown color. This will be a moving average as I test more fans. But in general, you want the fan to outperform this average. So with all that being said, noise normalized, the Cougar fan is the best performer at 1,110 RPM and 53.25 CFM. The other fans underperforming the composite average. At 100% fan RPM, none of these fans are really all that impressive. The ROG and the Cougar get somewhat close, but they're still lagging behind. And the Noctua is way off the average fan. The last graph here is RPM versus decibels, noise. The Cougar CF-V120HP is the top performer here. Unfortunately, when I last checked, it is out of stock. Cougar's current fans appear to retain a similar set of features to this fan, but as I have not tested them, I cannot verify if the noise profiles are similar. So right here, we have the average fan, and you want any of your fans to be under that line, which indicates a better performance. Lines over top of it indicate worse noise performance. So the Noctua and the ROG fans both are very unimpressive.
The Cougar fan.
One note about the Cougar fan here, its minimum RPM is around 600 RPM. Noctua NF-F12 high pressure radiator type fan. Asus ROG Strix. One odd behavior I was getting with the ROG Strix fan is I was getting a little bit of a ticking sound in there. I'm not sure if there's an imbalance in this particular fan or if it's the nature of the fan in particular, but I just wanted to make that aware in the testing that I was getting a ticking sound and it affected some of the results.
in the decibel rating and how the graph was reading certain sounds and amplitudes.
Recommend any of these fans at this point? Well, we've only looked at 3 so far. Please check out my other upcoming videos or videos already posted for more fans, as I will be also testing a lian-li RGB fan, as well as a bunch of other Noctua fans. So please check them out, subscribe for more content, and let me know in the comment section below what other fans you would like me to look at, so I can get my hands on them and test them out using this methodology. Now let's go ahead and take a look at the product pages and other product information about these fans. And this is the product page for the ROG Strix XF120. It's a 120mm fan by Asus ROG. Whisper Quiet for pen. This is the product page if you're interested in reading through it. Airflow and pressure, so got that hybrid fan design as opposed to just one optimized for pressure or airflow. Maglev bearing, minimize acoustic profile, Whisper Quiet 22.5 dBA as they're rating it. My testing will likely have different values because of different testing methodology. Aerodynamic fan blade and frame design. So that's just the different features on the frame itself for how the air is coming into it. So I just knocked my camera a little bit so you can see that the arced inward, although I will say that it's more or less a basic frame design, so take that for what you will. Extensive operating range, 250 to 1800 RPM, so that's pretty standard range, 5-year warranty. It's apparently won some awards. Whisper Quiet case fan radiator. It does not have RGB, but the front is holographic, if you care. We're going to be focusing on actual fan performance, not really aesthetics, although I will say I want my fans to look cool. So, la-da-da-da-da-da-da. Oh, they got a nice pretty graph. Noctua likes doing these too. So that's a static pressure, a fan profile. That's an air profile. And then, so you got static pressure in millimeters of H2O versus the airflow in CFM. So this is your a PQ curve. So radiator impedance curve. And then PC case impedance curve. And then this is how the ROG Strix fan in their testing kind of performed at various airflows versus static pressure. So again, you would have, I don't know again, depends on when this video comes out. So basically you would have a tube and you would have a different size restrictors at the end of it, and you open it up or make it smaller depending on which way you're doing the test. And so almost completely shut is pure static pressure. What is the maximum it can generate? Opening up all the way is how much airflow it can do. So that's how you get this curve basically, and you run it at effectively different RPMs, which equals different airflows. And then these are the maximums that it can do. So you're never going to get maximum airflow with maximum static pressure, basically. You're going to get one or the other, because you're not going to get maximum airflow that's 62.5 CFM through a radiator at that maximum static pressure. It's going to be somewhere on that curve. You realistically want airflow through the radiator, so you won't be generating the max static pressure, but high static pressure means that it's capable of pushing through as much as possible, and you do need that number for radiators. Mag levitation technology, so that's just the type of spindle that is inside the fan itself for rotating around. Maglev is pretty standard technology these days. Fiber reinforced material, minimize blade hub. Actually, you do want that hub as small as possible so that the fans are as large as possible for maximum airflow. What else? Okay, they also have two options. So blade grooves, I did not notice. Oh, on the back of the fan, it's got that groove, which probably helps similarly to how a little tiny fin on a lot of airplane wings work. So it just helps channel the air a little bit. But yeah, the fan is pretty unremarkable other than that. So what they're saying is without that groove, air tends to slide off the tip of the fan blade, and then because of that gap around the edge, it'll flow kind of actually out in the wrong direction, which reduces the capabilities of the fan. So that is actual science. It's not just pure marketing. How effective that groove is another matter. And for that, you would have to do pretty extensive testing that I just don't have the equipment for yet, or at hand. With direct flow frame, without direct flow frame. So the frame just helps direct the air straight out the back. Again, that's a little bit hard to test without a smoke machine. Again, I'm kind of in the market for it, but I don't have one yet. Dynamic balance pre-calibration, so that just means that the fan is calibrated to not wiggle as much as possible, which is good for vibrations and noise. And then they got precise, flexible PWM speed control, so that's speed RPM versus the duty cycle. So if you enter 20%, it should be this. If you enter 100%, it should be that, with very little fluctuation in the fan speed, and that's the end of their website. This is the product page for the NF-F12 PWN fan. Focused flow frame design, so that's just what they call their frame design, which helps concentrate the air into the back to essentially give it better dealing with radiators. Varying angular distance vortex control notches, so really would need to read into that. The angle feature of the vortex, so I think that's just the angle of maybe the fan blades or the back ridges on the fan that help direct the airflow. Hepterpf, I can't read that. Impeller, so custom designed for focus airflow frame. So Noctua doesn't just focus on like one aspect of blade design or fan design. So some companies will just focus on the blades. Noctua also looks at what features on the frame can they utilize to help get the most out of their fan design. So they look at all aspects of it. It's one of the reasons why Noctua fans are so well regarded, and they're relatively low acoustical noise compared to others of similar type spec. Stepped inlet design, so you can see these ridges. It just helps the air flow into the blades a little bit more smoothly. The dimpled surface on the inside. So again, that's like a golf ball. The vibration pads to reduce noise and vibrations. That was more important when we still used mechanical hard drives in the case, and if you still do, that is a great feature to have on a fan because it will reduce the vibrations going into the case. And as we all know, vibrations and hard drives do not get along. Metal bearing shell, PWM, the fan stops, ultra noise, ultra low power consumption. All right, let's take a quick look at the specifications section. Whoops, what did I click on? There we are. So mount hole spacing, the cable length, SSO2 bearing type, the blade geometry, what they're calling it, the focused flow frame. Rotational speed is 1,500 RPM. With a low noise adapter, it's 1,200. Minimum rotation is 300. Max airflow is 93.4 meters cubed per hour. And depending on when I release videos, as I mentioned before, meters cubed per hour can be converted to CFM, or cubic feet per minute. It is just the volumetric flow rate. low noise adapter flow rate, acoustical noise. My values will be different because of the way I am reading it, and everybody's test methodology is going to be slightly different. So you need to know how they got this number, whether they got it from what distance their microphone from the fan and where it was positioned next to the fan. Static pressure, 2.61 millimeters of H2O, so that's just basically how much pressure it can generate. Low noise adapter, its wattage, amperage it needs to input, the voltage it takes, all standard, 6-year warranty. Alright, here we are on Cougar's website, and we're going to be taking a look at the product information for the CF-V12Hp hydrodynamic bearing. So this was one of the first fans that I saw that had this hydrodynamic bearing. So first and foremost, if you look at this frame, it is not going to do as well for a radiator by today's standards because it's not a squared off shape, so air can leak out around it. But it should still be good for like a thin stack. Anyways, I just wanted to note that before I forget about it. Power management, 800 to 1500 RPM. RPM versus power management signal, 20, 40, 60, 80, and what the RPM related to it is. So that's a good amount of information there. Vortex, shaped airflow, turbine, blade, and pennant frame design. Standard PC fans. Cougar Vortex. So more airspeed for RPM. PQ curve, so that's airflow versus pressure in millimeters of H2O, and the airflow here is in CFM, cubic feet per minute. So a standard fan, the Cougar fan, and it's got these little nubs on the back that is supposed to help create a vortex and spiral the air. Honestly, this marketing is primarily why I bought it. I was like, yeah, focused airflow, that'll be great. And then I only used them as case fans. I never got around to using them for anything else. Strong and focused. So a focused airflow is best for case fans, and actually in my opinion for basically all fans, because it means it pushes the air through essentially the diameter of the fan rather than trying to make it spread out. So shoot air off to the sides. So you want it to have as much punch impact through whatever you're trying to push the air through. Again, in my opinion, you want the same kind of thing for case fans because you want to push the air to where you're trying to get it to go. But depending on what kind of case and setup you're doing, it matters a lot less. So potentially for a radiator setup, like AIO, your case cans can just blow air wherever to cool all the random components inside the case, and you're going to be drafting the air out of the case with the radiator fans. It has the grooves on the fans to help with flow separation. That's kind of good stuff. And this was one of the first fans I came across that had these isolation dampers on it to minimize noise. Normal fans at the time. Again, I bought these back in 2010. So this was all new stuff back then. So it'll be interesting to see how they compare to some newer fans that are out now. Aerodynamic design, streamlined profile as opposed to a normal fan that can create turbulence and is less efficient. Hydrodynamic bearing, oil seal, more reliable than conventional motor designs. Low vibration noise, fluid, sleeve, lifespan 3,000 hours, 30,000 hours. I wonder how much I've used it. A couple hours a night for, has it been 20 years? No, I'm not that old. 10 years, yeah. 2010, I can do math. So I'll need to do some math to know how old that is. Waste heat, high, cost, low, ball bearing, good, best. loud to quiet. The hydrodynamic is quiet. Oh, its lifespan is this. Sleeve is that. Hydrodynamic is that. Waste heat, low. Cost is high. So just some information. This is the one we were looking at. I didn't fully read this beforehand. Ha! Normal bearing can wiggle, wiggle, wiggle. Their bearing type, they're supposed to be more stable. And its specifications, they made a 140 millimeter version. 25 millimeters thick, standard case fan. 800 to 1500. The 40 or 140 is a little bit slower. Max airflow is NCFM, or meters cube per hour. So that's 70.5 or 119.8. Both fans rated at the same. Air pressure is 2.2, which is pretty good. Not the best anymore, but pretty good. Noise is, they rate at 17.9. I don't believe that for a second. I think that this is going to be one of my noisier fans, in my opinion. Power management, cable length. I don't know if I have any of these accessories anymore. And its lifetime. So I've been using these fans for like 11, 12 years. I think all of them. I had them in my Corsair 550D. So that would be 2 in the front, 1 in the back. And how many of these fans do I have? 1, 2, 3, 4. Oh, 1 at the bottom. So they've all been used for a long time, so we'll just see how well they hold up. All right, let's get on to the testing. In terms of performance through a cooler, the winner was easily the Cougar. Mind, I wouldn't recommend this for a radiator, but for an air cooler, this one was the top performer in these 3 fans. For like a case fan scenario, the winner again was the Cougar here. It just outperformed in noise normalized testing, just the amount of air that I could see through my anemometer moving through the case. Once we're looking at 100% fan speeds, the ROG ROG XF120 was the top performer. So it just performed the best, moved the most air through the cooler. And through the case, the winner barely was the Cougar with the, I almost said Noctua, the ROG Asus coming in second, and the, interestingly, pressure optimized Noctua coming in last. Here, even came in last in the cooler test. Now in noise profile, the loudest fan here was the Noctua. The second loudest was the Asus, and the quietest was the Cougar. So out of these 3 fans, the Cougar, as long as you're not going AIO or custom water cooling, appears to be the best. Now it is an older design, but as far as I can tell, it's still being sold. So if you're not looking for RGB, they do make an all black version, which I think was in my, will be in one of my other tests, but they're effectively the same. So anyways, thank you very much for watching, and I've got more videos of fans coming up, and please check them out. Anyways, have a great day. Conclusion time for this roundup of 3 fans. We had the ROG XF120 120 millimeter fan. Well, all these are 120, so I'm not going to state that for the further ones. The Noctua NF-F12 and the Cougar CP-12Hp. So by far the oldest 2 fans in this are these 2, with this one being a brand new model out this year. But overall, the performance was pretty drastically different between these 3 fans.